मैं थोड़ा लिंक भेज रहा हूँ, मेरे को व्हाट्सएप पे कॉपी करके भेजना, ठीक है? व्हाट्सएप पे कॉपी करके भेजना है, लिंक भेजा हूँ तेरे को। चल, हेलो। So, yesterday I have shared one test case in the group. Okay. So whatever we have done yesterday, so we have copied one test case from the simpleFOAM. Then we copy that folder into the our run folder, and then we have done simulation. Okay. So I have suggested that perform one tutorial from the icoFoam. So this is our terminal. Let's finish that example. First, we need to create OpenFOAM 9 environment. Okay. Okay. Then we can type run. So that way we can go inside the run folder. And after that, first we need to see that what are the different home tutorials. Then incompressible. Then I suggested that take one case from the icoFoam. So you can see that there are two cases is given, that is cavity and elbow case. So we can again list the cavity case. So again we have different cases related to the cavity. That is the cavity, cavity clipped, and cavity grade. Okay, some of the examples we are going to see today, that how this. So in these cases only the meshing is different. All has taken cavity case, but meshing is different, and we are going to see this example to understand the meshing today. Okay. Now if I go further inside the cavity, so there is this 0 constant and system folder, so we can copy this case. So you can use your up and down arrow, so that same command will repeat again. So if you type this top arrow, so if the commands that you are using, that will repeat again and again. So we can again use the cp command because we want to copy, and this r command because we want to copy the directory, and again we can put this dot because we want to copy at the present location. So dot means whatever you are doing, you want to do this process for the present directory. So if I do this, I have this cavity folder. Okay. Now we can go to the cavity. Yeah, so I will tell you, don't worry. So first to do this exercise, then we are going to focus on the day 3 folder. Yes, if you go to the cavity, then there should be, oh sorry, again I need to go to the cavity. So these folders should be present: 0, constant, and system. Okay. So everything: 0 is for the initial and boundary condition, constant is for the physical properties, and system is for the time control and schemes. So first thing we need to do is run the blockMesh. Okay, because we first want to create the, sorry, okay. So since I've copied this complete folder, so this cavity clip, cavity grade constant, so that's why I need to go to the cavity again. Okay, sorry. So this is the copy command. So cp means we want to copy, r means we want to copy the directory, and this is the location of folder that you want to copy, and this dot command because we want to copy at the present location. Okay, now after that we need to run the blockMesh command. Okay, so that will create the meshing. We can check meshing again. So this is the summary about the mesh you have created. So we have around 882 points. We have around 1640 meshes. These are the number of faces, internal faces, and this is the number of cells. Okay. So total cells are hexadral. So that is why the number of cells as well as the number of hexadra is same number. Okay. So now we have created the mesh. Now we can run the icoFoam solver. Okay. So its time step is only up to the 0.5. So that's why it is started from 0 and up to the 0.5. Okay. Good. So what you have to do if you want to plot? So we can use the touch command and then name of the folder and then maybe foam. So again, if I check, there is another folder that is the cavity.foam. Now I can use the paraview. So paraview will be open externally, and again we can use the explorer. So this will open this folder. So what we can do, we can just drag this folder. Okay. Now you can use this skip 0 time. So this is pressure field, this is velocity field. Okay. Explorer.exe. Dot is necessary because every time if you want to do anything for the present working directory, so you have to put the dot. Okay. Where is you are getting a
number of containers is somewhere in 0, 6. Okay.
परमिशन कैसे हुआ रहा
After clicking on, after typing icoFoam and getting a fat letter like in the FP solutions.
So
I
just
opened
go.
the FP solutions where the error I don't.
So instead of people, you need to put the PISO. PISO. That is written here. Na? PISO is undefined.
What is this password? I don't remember.
When you know your password. That's why I suggest that keep the simple password for this Ubuntu. Okay. Yesterday was it was working. You not install OpenFOAM?
OpenFOAM is there.
No, it should be sourced there. No? Study what with OpenFOAM.
Yes, sir.
Okay, 7 is installed. And it is installed inside operating. So we need to go to the operating. Maybe we can create one folder here.
Okay.
There. Just try to do this. Everything is
Like it is 2 years.
I think you have taken some other case.
Okay, cavity test.
You copied from. I think I've shared this folder. No, that is I'm taking from the OpenFOAM tutorial.
Okay, I have some cavity folder in my laptop.
Okay, so that
I
is
opened
different
that.
case. So your boundary condition may be different. Okay.
Exactly, learning.
Because you are opening the pressure and there is time step is 0.5. Sorry.
It's already there.
No, this formula 9 should be there. Similar to like that.
Okay.
Now you can go to the run folder. Then try to copy.
This one.
Yeah.
After this comes for to like zero constant system, that checkmesh and
blockMesh.
blockmesh and checkmesh.
Yeah. So you need to copy. Where you are copying?
I didn't copy.
Use this cp command. So I think most of you are getting. So this is the copy command if you want to copy. cp -r, this is the folder from where you want to copy, and this is dot. Huh? Run. Type this command. Huh? RUN, you can go to the run folder.
That doesn't work for me.
Maybe you have not created your run.
Is it because of this OpenFOAM 9?
Yeah,
Do I
you have to
it?
create. So if you type run, it is saying that create one folder with the name of the Rajesh 9. Then inside that you create the run.
Okay. So in OpenFOAM I have to create
this folder. Then after that you create. Yeah, I think you have not taken the case from the. You taking this case now? This case that I said. No, I'm saying that copy from the pitch daily case means icoFoam.
not just
So only because you are getting this because the number of cells is less compared to the my case.
Okay.
Solution is okay, but number of cells is in my case is larger. Okay. No, that blockMesh that I will teach you. So from there you can increase the number of cells.
Created the machine, but after that, what to do, like which like which simulation?
So you have to go to the back. Okay. Now we have meshes. So you can check the mesh. Mesh is okay.
Okay.
Now the solver name.
icoFoam.
Yeah.
Yesterday it was simpleFOAM.
simpleFOAM. Today we are taking from the icoFoam.
There is a difference in principle of solving.
The equation is different. Okay. So I will show you that everything. So you can now run the. So that will create the check the basic. Now you can run the solver name. अभी कॉपी नहीं किया क्या फोल्डर blockMesh, or you can check the command. If you use this row, you can check that what are the commands I used. First, this blockMesh, checkmesh, icoFoam. वो मिल नहीं रहा है Yes.
Good. Okay. ये मेरा डीएल टॉपिक है प्रोजेक्ट लाइक ये उसके लिए मैं ये कर रहा हूँ हीट ट्रांसफर चाहिए था मेरे को सो सिस्टम में बाउंड्री कंडीशंस मतलब कैसे चेंज कर सकते हो उसका बताइए
इसमें तो नहीं कवर हो पाएगा बिकॉज आज ही लास्ट सेशन है बट यू कैन मींस टेक्स्ट में आई विल हेल्प यू आउट ग्रुप में एड्रेस सेंड करके होगा ना
अच्छा कोई बात नहीं
because this is the p field if you go to the u it will show like that and the time is the different so for 0.5 solution will be like this. So I think most of you has plotted this graph. Okay, so see here different variables are given. So like u is the velocity, p is the pressure. If you want to see the pressure, this is the pressure. If you want to see the velocity, this is the velocity. And here is the time step. For 0.1, this is the solution. Because after 0.1, it is giving the steady state solution. That's why we are not able to see much changes. This is 0.5. Okay. So first open the para view. No, for foam file, you need to use the touch command. Yeah, dot foam file. This is the extension of this file. Got it? So you can put any name here, like cavity in case of this tutorial. Parafoam. Yeah, paraview. So this is the, like here you can see the view and P. And yesterday I told you that if you want to just see the middle plane, so you can go from here. This is the slice. From the left, it is the fourth one. Click on that. So it will show you plane. So currently we are using the X plane. So we can take, I think, Z normal. This is the Z normal. Done. And you should hide the plane because it will not show you means good plot. If I click now apply, so this is the middle plane. And this is the pressure. Again, I can see the velocity. Everyone has got the same? Again, let me repeat again. So this is where we all were. So we can take this fourth one, that is the slice. If I click on that, it will show something like this. And now I can go in the properties menu, slightly down, and I can click on the Z normal. So this will be Z normal, and I can hide this show plane, and I can click on the apply. So this is the pressure field for this middle plane. I can similarly plot the U. Okay. Everyone has this thing. That is maybe due to the I think your system issue. Okay. Now I can go to this one. This we want to change the color, so we can go to this thing. Oh. Yes. So if I go to the bottom from using this one, edit color map, that is the second option. If I go to the bottom, you can see the option choose preset. If I take any of these options that you want to prefer, maybe we can take this rainbow, apply. So this will give you this beautiful plot. And maybe I can change the background also. So go to the bottom and you can keep it as a this one. So this is the plot that we are getting for the cavity case. Which one? For the background. Which you want to see? Oh, background. So go to the second option. Then go to the this means use this cursor to down. Then you can use this one. There is a this use choose preset option. You can take this and you can use this one. Okay, now since we have kept the background as white, so I think we should also need to change this text that we can do from these things. Got it? So this we can again save this. So maybe we can use this save screenshot. Okay. I can like UZ because we are taking the normal of the Z plane and we can take is a whichever extension you want like PNG. I can save here. And here it is asking for the image resolution. So if you want, you can means down to 0.5x or you can extend to the 2x. Okay. Go to the file, then save screenshot. And here are the different extension is given here. So you can save it as a PNG and maybe you can give any name like UZ. And here image resolution is given. So you can also reduce the resolution and you can also means increase the resolution. So this is the 2x and I can save. Okay. So it is asking because means you are using Ubuntu into the other terminal and ParaView is installed into the C. You are, I think you if you open this ParaView, maybe it has been saved there. This is the diagram that we have saved. Okay. So this is the range of the velocity that is starting from the 0 and it will go to the 1, and the color map is showing the velocity field. Okay. So everyone has got this image. Okay. So this was the exercise that I has given you. Now let's go to the next part. Let's first understand the OpenFOAM directory structure. Okay. So if I type OF90, so it will again create the environment. Some people has directly sourced, so you don't need to use open OF90. Okay. So basically we use open OF90 to create the OpenFOAM environment. So if, it has been already created, so don't require to use this command. Okay. But now we can go to the we can press this command like cd and tab command, so it will suggest you multiple options. Okay, yesterday I told you that these are the just variable that has been defined inside the OpenFOAM. So if I after typing cd and this and press the tab, so it will suggest you the different options that is available inside this given environment. Okay. Now we can use this work WM project directory. This one we can take this. If you after selecting this, if you use Control C and Control V, otherwise you can just select it and press the right like mouse button, so it will copy. Again after going here, you can press again right button, so it will paste. Okay. We want to go to this directory. You can just copy from here. Huh? Press the tab. Press multiple times tab. 1 2 3 जब तक नहीं कर रहा है, you can try typing, it will suggest you. Okay. Now we can copy this pressing the right mouse button and then paste it. So we will directly go to the OpenFOAM 9 folder. Done. So now let's see that what is different folder structure of OpenFOAM 9. So you can use this command, that is the tree. I think you have not installed. So you can use this sudo apt type tree minus l into 1. So that will list you all the folders in the form of the tree. You might be getting error, so you need to install this sudo apt install tree. Everyone has this tree command. If you type tree minus l and that is 1, so you have to install this tree command. So it is giving you, suggesting you that how you can install. You can just copy copy that command and you can paste it. Yeah, so you can visualize the folder. So this is very good option, because if you type just tree, it will give you the complete file structure, whatever the last folder is given here. Okay. So there are other different commands that you can use, like use the help command. So it is saying that how can use the tree command. So you can use this a command if you want to list all the files. If you want to only list a directory, you can use the -d command. These are the different options that you can see. So like if I type only here d command, so it will list all the directory only. Okay. But what I am saying that I want to list only those folders which is only after one directory. So that's why I am putting here one. So it will list only those directories which is in the current folder. Okay. Yeah. So these are the complete directory that is present into the OpenFOAM 9 directory. Okay. So that is what I have listed here. Okay. All make copying readme.org application bin doc etc platform src test tutorial and wmake. Okay. Now let's see each by each every folder. So this all make is the compilation file. Okay. So remember that when I said that we need to install the third party and OpenFOAM, we used to put like that, something like that, or wmake. When I said that I want to install OpenFOAM 9, yes. So first of all, I used this OF90 command to create the environment. Okay. Now I said that if after pressing this thing, if you press tab multiple times, it will suggest you options. Okay. Some people might get in after only one time. So sometimes you have to press multiple times. So I'm copying this one. So to copy this, you can click on this screen and press your right button on mouse, and then here you can again press the right button. So it will automatically copy this. Okay. If you press here, now you will be into the this your working directory, working project directory. Now if I put this -3 -l into 1, so this will be all the folders which is present at the current location. Okay. So let's understand every folder. So I said that this all make is the compilation file. Okay. So it means that everything is given here, means what files you want to compile. So everything is given here. Okay. So first it will means use the third party. That's why you install the third party first, then we go for the OpenFOAM 9. So this is the complete script that we want to install the OpenFOAM. Okay. Now after that, these are the important three files, that is application, doc file, src file and tutorial files that we are going to use if you want to work with the OpenFOAM. These are the four important files, that is application, doc, src and tutorial files. Other files we don't generally touch. Okay. Got it? And I think we have already used this, that if you want to list all the things related to the OpenFOAM environment, grep -i and OpenFOAM that you can use. Okay. Now if we go further inside the application folder, so we have this means these are the different folders. Now we can go to the application folder, and again if you use this tree -l, we have these three folders: all make, solvers, test and utilities. Everyone has same things. Okay. All make, solvers, test and utilities. So here solver is all the solvers, means as I said you that if you want to solve any problem, any physical problem, you are solving some governing equation, and you are solving those governing equation on a given geometry. So to create the geometry, to create the meshing, to give the physical property, we have a test case. But what are the different equations that you want to solve? That is given inside the solver. Okay. Okay. Suppose, means I always give this example of the editing an image. So image is the test case, and the app which you are using for the editing is kind of a solver. Got it? So this is kind of a application. Okay. Now after solving the equation, so to solve any problem there are three steps. Okay. One is the pre-processing, second one is the solving those governing equation, or third one is the post-processing. Post-processing means the visualizing the results. So apart from this, solver is for solving the governing equation, but this post-processing and pre-processing is given inside this utilities. Okay. So if we go to the utilities, we have multiple options, like how you can create the meshing, how you can use the parallel processing, means if you have a multiple number of cores, how you can use those cores to solve your one problem. That is a parallel processing. This is the pre-processing. There is the post-processing. If you want to add some complex thermophysical model, that is also given here. There are some miscellaneous things are given here. This is the surface kind of properties are given here. So utilities is generally for the post-processing and the pre-processing. Okay. Now we can go to the meshing and see that there are different options for the meshing also, that is advanced option, conversion option, generation option. Okay. Now if I go to the generation, so you can see that blockMesh utility is given, extrude 2D mesh is given, foamy mesh is given, snappy hex mesh is given. So currently we are using the blockMesh utility. Okay. So how blockMesh works means how we can create the vertices, how we do the meshing, what are the different options, that all coded inside the blockMesh. Okay. So this application has three parts, that is the utilities, solvers and test. Okay. Got it? And the utilities is related to the post processing and the pre processing, and solver is to solve the governing equations. Test is generally the snippet. Okay, let me show you that. So test is something that if you want to understand that how particularly basic coding is done inside the OpenFOAM, so you may copy this folder inside your run folder, and you can see that how this coding is done. Okay, let me show you one example, I think. Okay, so you can see that a different how list works inside the OpenFOAM, how times work inside the OpenFOAM, how mkdir works inside these different things, that is depend for creating the files and other things. Okay, everything is given inside this folder. Okay, so maybe you can copy, means it is advanced. So if you want to learn a programming, so you can copy this complete folder inside your run folder, and then you can see that how the basic coding is done. Like tensor is given, how tensor works, how vector works, volume field how works, everything you can copy this folder and you can learn things. Okay, got it? This OD, that means one ordinary differential equation, that how can be coded inside the OpenFOAM, how polynomial works, that you can learn here in future when you want to learn about the programmings. Okay. So for now you should understand that what is solver and utilities. This test is something that you need to learn after the program if you want to understand the most difficult programming. From basic level, if you want to learn, that you can learn from here. Now further, if you go to the solvers, we can use this tree command. So different physics solvers is given here, like DNS, basic solver, combustion solver, compressible solver. So based on your problem, you can see that how the things works here. Okay. So you all are from the means, some are the from the chemical background, some people are from the means like mechanical. So you can choose best. So like yesterday I was saying that here one financial solver is also available. So this solves the equation for the option trading. So how option price can be calculated? This equation is solved using this financial. Okay. So like yesterday we were using the incompressible solver. So even inside the incompressible there are different type of solver. So like icoFoam is there, simpleFOAM is there, pimpleFOAM is there, pisoFOAM is there, non-Newtonian icoFoam is there. Okay. So this different solver has the different physics. Okay. Or different algorithm. So like simpleFOAM is particularly used for the steady state solver. Okay, which is independent of the time. And icoFoam is a transient solver. Okay. So this is something different. Piso algorithm is slightly different from the icoFoam. PimpleFOAM algorithm is different from the pisoFOAM. Okay. So that is something that if you learn the simpleFOAM algorithm, that you can understand here. Okay. But just if you want to see that, particularly you should know that what solver is doing. So that you can go to the particular solver. Like if you go to the simpleFOAM, so there is 3 files. That is the UE equation, create fields.h, PE equation.h, and simpleFOAM.c. Okay. So if you want to know that what simpleFOAMs generally solve, so you can use this any editor, like you can use the gedit and simpleFOAM.c. So that is source file that you can use, and you can open this. Okay, so it will open something like this. So you can see that description is given here. So this is the solver for the steady state, solver for the incompressible turbulent flow using the simple algorithm. I think maybe I can use the. So one another editor is the Genie. So that is the means more compatible with the OpenFOAM compared to gedit. So you can install this Genie if you don't have. Okay. So you can see that it is saying that steady state solver for the incompressible. Okay. So that way you can see any solver that how this works and what are the different means conditions. So if you want to solve a steady state problem for incompressible, and you also want to include the turbulent model using the simple algorithm, then you can use this solver. Okay. Similarly, you can go back, cd double dot, you can go one folder back. And similarly, we can see about the icoFoam. See if I type icoFoam.c, so you can see that it is solved for the transient solver for incompressible laminar flow of the non-Newtonian fluids. So if you want to solve the transient problem and you have only incompressible and you don't want to include the turbulence model, then you can use this solver, that is icoFoam. Got it? So for any solver, you can see that what are the different physics it is being solved. So based on the problem, some people has heat transfer related problem. So you can just go to that solver and you can see that. And if you want to modify, you can modify further. Okay. But this is something important that you should know that what are the different problem is being solved. So that is something related to the application folder. Now we can go to the 3 folders back. Okay, so I've all written the same things. Now this bin, so when you compile any solver, okay, so like when we type all make, that is compilation file, while we are installing the OpenFOAM, so it were creating application for all the solvers. So all the things is available inside this bin folder. Okay, everything that we want to create, we can create using the this bin folder. Got it? So that we don't need to means change here. We just something we use this thing. We don't need to go to this folder. But you should know that what this folder is mean. Okay. We can again skip to the. So this is the doc season. So if you go to the doc folder, you have this user guide. So other things you can use the webs, this browser, that is also a one means good source. So you can type OpenFOAM user guide. Okay, OpenFOAM 9 user guide you can type, and this is the CFD direct. So all the things is given here. Okay, from starting from the means running your first tutorial to the how you can understand the models and physical properties, all things are given at this location. Okay, how you can go just type user OpenFOAM 9 user guide, and you can click on the first link, and it will give you all the things that you want to understand. Okay, so like if you want to understand the programming also, that you can start from here, but it's a very advanced means it is this user guide assume that you already know some means advanced C++. So that way this user guide has been explained, that you know that what is inheritance, what is the polymorphism, what is the means abstract class. So this user guide assume that you already know these things. Okay, so that you can use if you want to understand. And after that, this is the etc. Okay, so all the environment variables is coded inside the etc. So remember that when we used to source OpenFOAM 9/etc.basrc, so that basrc and different environment variable is given inside the etc folder. Okay, so that is also that we don't need to understand this. And this platform contains the binary files of the all the compiled solver and libraries. Okay, so this folder we also don't generally touch. This is the main core of the OpenFOAM. So all the variables, all the meshing generation, how it happens, it all is given inside the src folder. Okay, so we can say that this is the means mind of this OpenFOAM. Okay, so if you are means advanced developer inside OpenFOAM, you should know that how src folder works. Solvers you can do, I think after 1 or 2 sessions you can understand it, how you can run your solver, how you can edit your solver. But if you want to understand the base means I think mind of this OpenFOAM, you should understand this src folder. Okay, if you are capable of compiling libraries or boundary fields, sorry, boundary condition, you are master of the OpenFOAM. Okay, so that I think you should try using some tutorials from the YouTube. And this is the tutorials that we are already using from the last study class. Okay, so this is something about the all the OpenFOAM directories. I will save these files, and you can just try to go from your side, just use the terminal and go to each and every directory and understand that how this OpenFOAM has been organized. Okay, got it? Now let's understand the meshing, then we will go to the programming. Okay, so I think you have all copied this folder that I've shared you. I ask that you copy you download this day 3 folder. and you can copy manually. You can go to your run folder. Yeah, so that's why I'm saying that manually, because in Ubuntu terminal you cannot get access to the C file. So in Ubuntu terminal you cannot get access to the means like Windows installed. So that's why you can just copy from here, like no, because terminal only works for the OpenFOAM, sorry, Ubuntu. So you can copy this manually, and we can go to the. Okay, now remember that in some users, some of the people has installed inside the OPT. So you need to go to this OPT folder, and some people has installed inside the home folder. So you can go to the home, then your user folder, then OpenFOAM, then there is a run folder. So you can copy here. So like I copied this folder, that is the day 03. Just open on the Linux. Here, this side, left side. Linux. In my case, I have installed 2 Ubuntu, but in your case, there should be only 1 Ubuntu. Okay. You can open this. So these things will be open. Some people has installed OpenFOAM inside OPT folder. Okay. And if you have in home folder, then you can go to the home. Then this your run folder, sorry, your username folder. Then here you can go to the OpenFOAM. Then there should be username -9. So in my case, the username is itrasim, then dash, then 9. Then you can go to the run folder. Then you can paste here. Okay. You can paste here. So I have, yeah, zip file. Now you can extract it also. Yeah, that you can also do. You can extract. Okay. Okay, let it extract it, then we can learn something about the blockMesh. Okay. So you should copy inside your run folder. So where we were currently running cavity case, in that folder you should copy it. Okay. You can copy anywhere, but means I suggest to run inside run folder because it will be organized. Okay, you can run from anywhere inside Ubuntu terminal. Okay. ओपीटी में मत कॉपी करो ना, अभी कहाँ पर केस
विंडोज में है।
हम्म,
मैंने यहाँ से कॉपी किया है वो वर्चुअल बोर्ड पे कहाँ पेस्ट करूँ?
भाई आप तो ubuntu कर रहे हो ना, इसमें वो ऑप्शन आता है ना जब इंस्टॉल कर रहे हो, उसमें से पेस्ट करने का ऑप्शन आता है।
तो मेरा मैं अभी फिर ये रन फोल्डर है इसमें
आप करो, नहीं आ रहा क्या पेस्ट? यहाँ से डाउनलोड करो,
इसमें डाउनलोड
वो जो ड्राइव दिया ड्राइव पर लिंक से भी कर सकते हो डाउनलोड। हो गया, एक्सट्रैक्ट करो।
डायरेक्टली कॉपी हो गया था वैसे।
गुड, बट सम केसेस डोंट वर्क। हो गया ना कॉपी? ओके गुड। इंस्टॉल नहीं करना है, मैंने एक केस शेयर किया था
डेट की वाला
डाउनलोड किया कि नहीं?
हाँ ये तो
इसको कॉपी करना है एंड यू नीड टू गो टू द योर उबुंटू, यहाँ से होम फोल्डर में जाना है, इसमें जाना है, फिर ओपन फॉर्म इंस्टॉल है, फिर आपके इसमें जाना है, फिर रन में कॉपी करना है, उसको एक्सट्रैक्ट करो। क्या से क्यों नहीं हो रहा है? दो दो रखे हो फॉर्म। मेरा भी इंस्टॉल ही नहीं है, मेरा भी इंस्टॉल करो।
इंस्टॉल किया था जो सुडो
नहीं वैसे नहीं, सुडो से इंस्टॉल नहीं करना। इसको इंस्टॉल करो, यहाँ पे डाउनलोड हो रहा है। Okay, so let's understand the meshing. Okay, so we are going to learn about the introduction about the meshing. Then particularly we are going to focus on the block mesh, and maybe we'll take some examples. Okay, so today's learning outcomes of this session would be how meshes works in the OpenFOAM, then block mesh utilities, and how we can modify the block mesh dict. Okay, so if we see, I show you this like if we I show that what are the different options that you can use to generate the meshing. So like in OpenFOAM, there is option of the block mesh. Second is option of the snappyx mesh. Foamy mesh is also one utilities, but mostly widely used is the block mesh dict and snappyx mesh. Okay, and both are the very powerful tool. Okay, any kind of mesh, if you know this block mesh and snappyx mesh, any kind of mesh you can generate. Okay, even means just talking about the snappyx mesh, it has around more than 60 parameters that you can tune, and you can create means very fine mesh, very good quality of mesh. You can use snappyx mesh and even using the block mesh. Again, if you are not confident with this block mesh and snappyx mesh, you can also use some other softwares like NSYS, GMS, Gambit, and other utilities you can use. That is the external software. You can create your mesh using those software, and then you can export it. And these are the different options is given, like you can export from the NSYS to foam, CFX to foam, Fluent 3D mesh to foam. Okay, Gambit to foam, GMS to foam. So these are the different other external software that you can use to create the mesh, and you can again export it. Okay, okay, so first is option that is the OpenFOAM inbuilt, that is the block mesh and the snappyx. But if you are not confident about these two tools to create the mesh, then you can go for the this other external software. Okay, so this is we are going to learn about the block mesh, and you can see that a number of different kind of geometry can be created using the block mesh. So this is very complex. You can see that you can create the cylinder, you can create this kind of the geometry, using the blockMesh. Even this kind of the curve kind of the type of the mesh is you can create. And yesterday I told you that what is advantage of this blockMesh. You have hex dominant meshes. Okay. So means one of my friend is trying to solve the problem of the ISRO. He tried to create meshing using the NCs, then Fluent and other utilities he has used. Then finally his solution was not converging. So finally he switched to the blockMesh dict. I think he has taken around 2 months only to create the meshing using the blockMesh. But once he has converted this mesh into the blockMesh, his most of the problem was solved. Okay. So in my experience, if your geometry is capable of creating some geometry using the blockMesh, you should first try the blockMesh dict. Okay. Only some complex industrial problems like you have like some motor which has a different number of bolts and nuts, then in that scenario you can use some other tool. But your problem is simpler, then you should go for the blockMesh dict. Okay. What is advantage of that blockMesh create everything into the blocks. Okay, study I tell you that a block is made up of the 8 vertices. Okay, so even if you want to use like this cylinder, if you want to create, you have to create the first block, and using those blocks you can create the curve kind of the shape. Okay, so that is why since it creates the blocks, that is why it creates the hex dominant meshes. It try to create most of the hexagonal kind of shape. Okay. So, and how you can find this blockMesh? So there is a blockMesh dict file which is situated inside the constant folder, sorry, system folder. So yesterday I told you that there is a 0 constant on system folder. So blockMesh is situated inside the system folder. And once we create the meshing is generally you can find inside the constant polymesh folder. Okay, got it? So let's take one example. So I have shared you one file that is the tree. So let's go to our run folder. Go to the run folder, and we can go to the J03 folder. If you have unzipped it, you might have this folder J03. Okay, sorry. Okay, so you are inside the run folder, and if you have unzipped this, you may have this J03 folder. So we can go to the J03. Okay, again we can go to the one inside directory. So we have different cases, that is the case 01, case 02, case 03, case 04, case 05. But before starting the case 01, I have also one. So go to the understanding meshing, and I have 2 folders, that is a case 00 and case 002. So let's open the case 00. So I think you all are up to here. Yeah, inside J3. So there will be two times J3. So you should go inside that folder. Then go to the understanding the mesh. Okay. Just try to use the tab button. Okay. Understanding the mesh. Case 00. So you have 2 folders, that is the case 00 and case 002. So let's first start with the case 00. Okay. So if we go to the constant folder, so we don't have any other file like polymesh. If you go to the constant folder, so there is no any folder like polymesh. It means that we have not created mesh till now. Okay. So let's run the blockMesh. So now you have created this mesh. Okay. No. So where you are running the blockMesh or any command, you should see that these 3 folders should be present. If you are running from the system folder or constant folder, it will show you error. Okay, so after running this blockMesh, if you go to the constant folder, so we have this now this polymesh. Okay, so that is the something which contains all the meshing related file. Okay, so further if we tree this, sorry, inside polymesh, so you can see that we have boundary, faces, neighbor, owners and points. Okay, boundary, faces, neighbor, owner and points. Okay, so before going to the blockMesh dict, okay, let's understand that what is this boundary, what is faces, what is the neighbor, what is the owner and what is the points. Got it? So let me go 2 folder backs and we can create again this .foam. Now I can open the explorer.exe and I can open the paraview. So what I've done, I've created this touch.foam extension. Then I have opened this file. Now I'm going to open the paraview. This touch, because I want to create a .foam extension. And then I'm opening the current location, that is the explorer.exe. Now I can use the paraview. You have to first, you have to touch, you don't, what you are using. You might be typing this as like this. Okay. You need to use the touch command. Now we can drag this. So this is the block that we have created. After touch command, we need to use this explorer.exe. Sorry. This .foam that you have created using the touch command, that you have to drag. You have to use the paraFoam from here, paraview. You can type in the search bar, that is the paraview, and after opening this, you can drag this. Okay. Now if you see here inside the surface with edges, sorry, just drag this, then apply. It might be showing you green. Let me again start from 0. So I have opened this, then I can drag this. Okay. So after clicking on this, then you should apply. Okay. So if you go to the surface with edges, So I have just created one mesh in each direction. To make you understand this, I have created only one mesh in each direction. Okay. So let me show you blockMesh folder, blockMesh dict. Okay. So what part basically we have done? We have created this block that has total 8 vertices. You can see that. How many edges are there? 8? No, 12. 12 edges. So you can see that we have total 8 vertices. So this is the 0, 0, 0. This is 1, 0, 0. This is the numbering. So C++ by default start from the numbering 0. So that is why this is the 0 vertices. This is 1. This is the 2. This is the 3, 4, 5, 6, 7. Okay. So ignore this because I have this commented out. So what I am doing that using this vertices, that is the 0, 1, 2, 3, 4, 5, 6, 7. I am creating one block. Okay. So I am joining each vertices. So 0 to 1, then 1 to 2, 2 to 3. Okay. Everyone is able to get this. So first I have created this 8 vertices starting from 0 to 7 because C++ numbering start from the 0. Sorry. This is the blockMesh file. Go to the system and you can use your favorite editor, maybe Genie. Okay. It is visible. I think Vim is more comfortable. So just opening this blockMesh dict file. Okay. So what we have done, we have taken 8 vertices. Okay. Got it? Suppose we want to create one more vertices, then we can just extend this. Okay. I will show you. I have one example for that purpose also. But let's first understand how this polymesh works. So we have these 8 vertices, and then by using this, like we have total 8 vertices, I am connecting 0 to 1, 1 to 2, 2 to 3. So that will kind of a one plane. That will be kind of one plane. So like this is the suppose this is the top bottom surface we have created using this thing 0 to 1, 1 to 2, 2 to 3. Okay, and similarly this top bottom, that is 4, 5, 6, 7. And then we are mapping 0 to 4, 1 to 5, 2 to 6, and 3 to 7. So that will create one block. Got it? And since we are keeping only one means one mesh in x direction, one mesh in y direction, and one mesh in z direction. That is why we are getting only one cell. Okay, got it? It's I said there is one C++ coding is written. So when you type this 0, 1, 2, 3, 4, 5, 6, 7, so it will automatically create one block. Okay. That will, so there is one rules that you need to follow to create block. That will I will explain you. Okay. How this numbering should be done? There is one rule. Okay, that is known as the right hand rule. Okay, that I will explain you. Okay, got it? This edge is used if you want to give some curve. Suppose you want to put that there is not a straight line, there should be one curve. So that edge command is being used. Okay. I have also one case inside this given folder to create one like one pipe. I think that is the case 3 that you can see that. So if you want to create one, suppose you want to have one curve between 0 to 1, so then you can write inside this edge. Okay. How you can write this? You can have one file inside case 3. If I time permits, I will show you. Okay. Otherwise, means there are many tutorials available on YouTube. Okay. Now we have total 6 surface. How many surface? 6 surface, one cell, single cell. And all the cells inside that is called the means internal cells. But this outside surface is called as the boundary faces. This is called as the boundary faces. So we have around 6 boundary faces. Okay. We need to give the boundary condition to those surface. Okay. So that is why we define this boundaries here. Okay. So like we are defining one boundary here, that is the min x. We are giving that it is the type of wall. So like different type is given inside the blockMesh. Okay. Again, how you know that what are the different types? So yesterday I told you this banana technique. You can just type any means any kind of name. It will suggest you the option inside the terminal. Yesterday we done about the RAS model. We have just put some random name and it will suggest you the naming. So similarly you can do here. If you know that what are the different types, like wall is given, base is another type, symmetric kind of boundary condition you can apply, empty kind of boundary condition you can apply. Okay. Patch kind of boundary condition you can apply here. Okay. And this is the what are the different coordinates you want to select to create this face. So we are using this numbering from here vertices 0, 4, 7, 3. Okay, so that will be, I think, if you this is x direction, so I think this face 0, 1, I think 0, 4, 7, 3. So 0, 4, 7, 3. So this minimum x boundary condition we are selecting here. Got it? Similarly, you should know this value. Okay. Yeah. For one block, we are just so I have created only one cell for now, just for the understanding purpose. Okay. We can increase the number of cells. Just give me a minute. Okay. First, let's understand that how this boundary means meshing works. Got it? Similarly, if you go to the max y, so max x will be, I think, this side. So this surface will be max x. Okay. So similarly, you can create the different means a different min z, min x, min max z. You can also combine the multiple boundary files. Like if you want to just give these two faces as a single boundary, so you can write max z and you can copy this up to here. Okay. So you can select multiple faces and you can just give a one name. That you can also do here. Okay. Understand? Now let's see the polymesh folder. So if I go one folder back, there is a constant, and then I can go to the polymesh. So there is the boundary, faces, neighbor, owner, and points. Okay, sorry. So we can go to the case folder, then we can go to the constant. Okay. Then we can go to the polymesh. So we have boundary, faces, neighbor, owner, points. Okay. So let's see these points. You can use your own editor. So you can see that we have this total 8 points. because we have defined only 8 vertices. I think you can now correlate these things. Now one confusion you may have, that why this is 0.001 dimension. Okay, so let me show you. You don't need to go back like me. So let me show you blockMesh dict. So we are defining 1, but convert to meters we are giving 0.001. So it will multiply with this 0.001. Okay, got it? Now we can again go to the so I think you can understand that we are just creating 8 points. So we have a multiple vertices, so there would be multiple points. So we have just only 8 points. That is the 001, 0.001. Then this is the y. Similarly, this is the total 8 vertices. Okay, understand? Now after that, we can understand the faces. So you can see that total we have 6 faces. So we have how much faces? 6. Understand? So it is selecting the vertices, that 0, 4, 6, 2 will create one face. Similarly, 1, 3, 7, 5 vertices will create one face. So how many number of vertices is selecting? It is also written here. So total how many faces is there? 6 faces. Okay, and also we have defined these boundaries. So this is the boundary. We have created min x, max x, min y, min z, and max z. Okay, got it? We have total how much boundaries? 6 boundaries. 6 faces means 6 boundaries. Okay. So I think you have understand that how this point is creating the faces and faces is creating the boundaries. Okay, got it? Now let's increase the number of edges, number of cells. So let's go to the system. Go to the system and let's edit the blockMesh. So we have just one cell. Maybe we can take a number of cells. Let's just keep two cells. 2, 2, and 2. So in X, this number of cells we used to keep 1 in X and Y and Z direction. Now we're keeping 2 cells in X, 2 cells in Y, and 2 cells in Z direction. Got it? So tell me how much cells would be there? Huh? 2 multiply 2 multiply 2, total 8 cells. So let's go one folder back and now run this blockMesh dict. Okay. Now let's check mesh. So now how much points would be there with us? Total 27 points. You understand? Earlier, sorry? Yes, VI file. So if you are using VI, so if you want to enter, you know that you should enter the I. Okay. Then you can edit wherever you want. Okay. Then press escape button first. Escape. Then put the semicolon W, Q and this override. Okay. And press enter. It will save this. Then go back and run the blockMesh. Then we can run the check mesh. So we have how many points? 27 points. Understand how? Got it? We are dividing one edge into the two parts. Okay, so earlier there were 6 points. Now it will be around 27 points. You can count it. Total 6. 6 plus how much? 6. 6 plus I think 4. 27. Yeah, 9 plus 9 plus 9. This way it will be 27. And how much faces? 36. Got it? So one face, there is only one face. Now there will be around how many faces? 4 face outside. So total 4 into 6, 24 faces. Okay. And there will be around 12 faces inside, that is internal faces. So that would be around 36 faces. So you can see that there is internal 12 faces. Got it? I think you can relate this. Earlier there is only one face. So let me show you. I think that so you can do this refresh. Okay, it's not working. Yeah, I thought that it will work, but it's not working. You can delete it and you can reload that. Okay. So I think you can relate now. There is earlier one face, now there is a total 4 faces. 4 is to 6, that is 24. And there would be around 12 faces inside. So 24 plus 12, 36. Understand? So that is why here total 36 faces and internal faces are 12. And how much cells would be there? 8. So this is 1 cell, 2 cells, 3 cells, 4 cells. 4 cells top, 4 cells down. So total 8 cells. Understand? Earlier there was only 1 cell, now we have total 8 cells. Okay, so these other things we can also check. And all the cells are hexadra. Means you are creating like a box kind of cells, that is the hexadra cells. Okay. And this is the bounding box that is also need to check. You also need to check the orthogonality. It is saying that it is okay. So I think our mesh is okay. Okay, now let's go to the again constant and polymesh. If I type now points, you can see that there are total 27 points. Okay, what are these 27 points? So 1, 2, 3. Similarly, there would be 3. There would be 3. So at the bottom there is 9 points. Similarly, at this level, at the middle level, there is 9 points, and there is top level, there is 9 points. So total would be 27 points. Okay. Now you can see the faces. So using this 9 points, it is creating 36 faces. And each face is using 4 vertices. That you can see the numbering here. Now from where this numbering is coming? This 1, 4, 13, 10, 3, 12, 13, 4, from where this numbering is coming? Yeah, but from where? But from where this index is coming? We have defined only 4, 6, 8 vertices. In blockMesh dict, we are defining only 8 vertices. But it is giving 13, 12. Yes, yes. Yes, exactly. So from here it is giving. So it will start from the 0, 1, 2, 3, 4 up to the how much? 26. Because it starts from the 0. So if you go to the faces, you have the maximum number that you would see, that is a 26. This is the 26. Okay. So it is taking points from the points folder. Then using those points, it is creating faces. And then using these faces, we are creating the boundaries. Okay. So like this min x, earlier there is only one face. This min x, there earlier we have only one face. Now how many faces is there? 4 faces. Because this is the min x. This is the complete boundary condition is the min x. How many faces are there? 4. So that is why it is saying that number of faces is equal to 4, and it will start from the 12. So 12, 13, 14 and 15. So this is the indexing of these faces: 12, 13, 14 and 15. Similarly, if you go to the max x, so it would have also 4 faces. Max is this face, so it is also 4 faces, and then indexing start from the 16. Okay. So similarly you can see for the other faces. Got it? So how this polymesh works, I think you can understand now. So you can create any kind of the geometry. So you can take this 20, 20, 20 examples. We can create the so you can take this example. So you want to create 20 cell in x direction, 20 cell in y direction, and maybe 20 cell in z direction also. Okay. You can use any editor. You can use the Genie, Gedit, Vim editor. Let's save this, and we can run this blockMesh. So now we have how many cells? Can you guess? Let me check. Eight 8,000. 20 multiplied 20 multiplied 20. So that would be around 8,000 cells. Okay. So we can again reload this. So this is the our cells. Okay. Same file. So go to the system and blockMesh dict. Then you can, in x direction you can keep 20 cells. In y direction you can keep 20 cells. In z direction you can keep 20 cells. Okay. Now go to the system.
Here it comes.
blockMesh.
After 20,
20 in x, 20 in y.
Z direction will 20.
We have to print out this one. Comment out this. So there's one folder back. And so this comment. Control S. Go to the surface with edge. ब्लॉकमेश डाउनलोड किया पैराफॉर्म से नहीं होगा पैरा व्यू आपको यहाँ से खोलना है जब भी डाउनलोड होगा हो गया इसके बाद क्या करना है इसको ठीक है इसको एक्सप्लोर ऐसे खोलना है इस फोल्डर को क्या कर सकते हो इसको ड्रैग करना है एक अभी एक ही सेल क्रिएट किया you've done this blockmesh now you can check the ठीक है अब पैराफॉर्म एक्सटर्नली ओपन करना है इंस्टॉल नहीं किया ना सब पैराफॉर्म इंस्टॉल करो जो भी ब्लॉक हमारा आ गया सेव कर सकते हो। blockMesh sorry no problem accept let's say anything is वैसे कलर कोड है ना सॉलिड कलर
यहाँ पे पैराफॉर्म बिल्ट इन करके ओपन किया और मेरा जो उबंटू है वो WSL में है और पैराव्यू C ड्राइव में है, तो यहाँ से तो अभी इसको इसमें उबंटू में इंस्टॉल किया।
बेसिकली एक्सटेंड उससे क्यों नहीं कर रहे हो आप?
कहाँ से एक्सटर्नली वो ड्रैग नहीं हो रहा है और वहाँ पे जब एक्सटर्नल ओपन कर रहे हैं तो उसमें लोकेशन में वो WSL वाली फाइल ही नहीं आ रही है। क्रॉस करना चाहिए। ड्रैग भी कर रहा था मैं तो ड्रैग की ओके वो यहाँ पे आ नहीं रहा था। अभी क्या आ गया
ये दूसरा फोल्डर खोलेंगे I think you can now understand that how this blockMesh works, huh? So let's take advanced examples. Okay. Actually, you can visualize into the Ubuntu because here we are using ParaView externally. So here you cannot visualize, but you have Ubuntu system. Once by default installed Ubuntu system, there you can visualize it. Even the number, even the blocks, everything. Huh? So for that you have this command parafoam block. So that will visualize each number, each block. Okay. Yeah, OpenFOAM installed in the Ubuntu system. So in that case, ParaView work as a part of the OpenFOAM. So that you can visualize this. Here we are using ParaFOAM externally and Ubuntu externally. That is why we cannot visualize there. Okay. I mean say that like in your system there is a Ubuntu Windows. So inside of Windows we are using WSL. But if you have like a completely Ubuntu system, so generally means I think if you have workstation, so you can do this. You can each every block you can visualize. Okay. Just you have to type this command, this parafoam block. It will so that each numbers and each block. Got it? So these are the different keywords if you want to use the means block mesh. So these are the different, this like first convert to meters that I will already show you. Okay, so you can have number like 0 to 25 you can use, then you can use the convert to meters, you can use in centimeter or micrometer. Okay, like microfluidic problems, micro channel, if you are working, the dimension is into the micros. Then there is a vertices that we have already seen, blocks we have already seen, edges already seen, boundaries we have already seen. And this merge patches, sometimes we need to merge different patches. Okay, so like if you want to merge two different blocks and two different patches, so in that scenario, this merge patches pairs you can use. So I think I already explained that you have to start from the 0, 1, 2, 3, 4, 5, 6, 7. This way you can create a number of vertices. So suppose we want to create this kind of block that you are seeing on the screen. Okay. So it will start from the 0. So it has vertices 0, 0, 0. Got it? That is origin. Then we are giving 1, that is 2, 0, 0. So we are going in along the x direction. So that is x direction is this direction. Okay. I think this is better way. So this is the x direction. Okay. So along x the dimension is 2, 0, 0. So y is also 0, z is also 0. Then from 1 we are going towards 2. That is along this direction. So we are increasing the y direction with 1. So that is 1, 2, 1, 0. Okay. Now what will be what vertices for this, coordinates for this? So x will be 0. Okay. Y will be 1. Z will be 0. So this is the 4 vertices that bottom one. But similarly there will be, we are just extending z up to the 1.2. So we will keep the same, the x, y and will be same, just we will add 1.2, 1.2, 1.2 and 1.2. Got? Understand? Now there is one catch that you need to follow, that we need to follow this right hand rule if you want to create this block. So now you have created the vertices. Now the next is the to create the block. So we need to follow this right hand order vertices. So take your right hand, and this is the rule. So use your index finger along x-axis. Okay. Middle finger along y-axis, and thumb is along z-axis. Okay. Got it? So this should be direction. This direction you should follow when you are creating any means this block like this 0, 1, 2, 3, then 4, 5, 6, 7. So this rule should be followed. Otherwise, it will show you error. So suppose you are using this. I have given one example. Suppose you are using 1, 0, 2, 3, 2, 4, 5, 4, 7, 6. Okay. So that will also we are selecting the same plane. But since we are not following this right hand rule, it will show you error. Understand? So that you are also saying 1032. So 1032. So we are starting from 1032. Okay. So this is not the right hand rule. Sorry, you have any confusion? No, here I've given one incorrect example. So at the bottom, see that I've given one incorrect example. So that is not following the right hand rule. So it will go show you error. So always try to follow this right hand rule. So x direction, this index finger, y direction, this middle finger, and z direction, this your thumb. Okay. And when you are able to create this plane 0, 1, 2, 3, so just whatever the mirror image is at the top, that you can place for the plane 2. So like at the top of the 0 there is a 4, you can place 4. At the top of 1 there is a 5, that you can place 5, 6 and 7. So this way this hex 0, 1, 2, 3, 4, 5, 6, 7 will create one plane. Understand? Okay. Now I think you already understand of this meaning. 20, 10, 12 means x direction we have 20 cells, y direction we have 10 cells, and z direction we have 12 cells. This I think you can understand. Now this is very important, that is the simple grading. Okay. So yesterday I told you that sometimes we don't require uniform meshing. We want that near to the ball meshing will be larger, and inside the middle the meshing will be smaller. So in that scenario we use this simple grading. So what is logic behind this simple grading? So this use the okay. So first let's case 1, then we will understand the simple grading using another example. Okay. Now go to the case 1 folder. Go to the one folder back. Then again one folder back. So here you should be inside day 03 folder. Okay. Now you can go to the CD case 01. Okay. Okay. You can open the blockMesh dict just to see that how blockMesh has been written. Okay. So you can see that this is 1, 2, 3, 4, 5, 6. Sorry, 0, 1, 2, 3, 4, 5, 6, 7. And again we are following this right hand rule. So 0, 1, 2, 3 and then 4, 5, 6, 7. We have 20 cells in X and 20 cells in Y. Okay. And these are the boundaries. So that is what something I was saying, that you can keep multiple faces in your single boundary name. So we have fixed wall for this 3 cells, 3 faces. Okay. What? Because if you want to do the boundary condition inside the 0 folder, so for the different faces you have to only write one boundary case, one means value. So that is why we can keep multiple boundary faces here. So we can go to the one folder back, and now we can run the blockMesh. Okay. Again we can use touch command. And we can load this. First you have to delete this in your why you install this blockMesh? You are using right now, so how it is possible? You might be not creating OpenFOAM environment. Try to always source OpenFOAM. Sorry, you have to create this .foam using the touch command, and after that you have to use explorer.exe, and we can drag this. So this is the blocks that we have created. So you can see that along Z direction we have only one cells, and along Y there is 20 cells, and along X there is 20 cells. So this is the Z direction, this is X, and this is Y. Okay. So this is also similar to the last example. Got it? This is similar to the last exams. We have not done any advance here. Let's understand the second example that is related to the simple grading. Okay. So first we started with the vertices. You already know that what is vertices. Then we understand that what is the hex. So using this hex we are creating a block. Then after that we have to this simple grading. So this is important, this simple grading. Okay. So what is concept behind the simple grading? That the width of the end cell but by width of the start cell is equal to the cell expansion ratio. Okay. What I mean to say that you understand from this, again these examples only. So let's go to the system and let's open this blockMesh dict. Just do with me also. Open. Now here you are seeing this simple grading. It is given that 1 1 1. Okay. 1 1 1 means the grid size is uniformly distributed along x-axis, along y-axis, and along z-axis. Okay. Now when I put here, suppose I am putting here some value equal to the 2. So what is 2? 2 is saying that the width of the end cell, that is the 20th cell, by the width of the first cell, that is the one cell, should be equal to the 2. Got? So that is for the x-axis. Once again I will explain. How many total cells are there in x direction? 20. So if you are putting a 2, so the cell will be distributed in such a way that the width of the last cell divided by the width of the first cell should be 2. Got it? Suppose this is in last cell there is a 0.02 the cell width. So what would be the first cell width? 0.01. Okay, and other cells are distributed in such a way that it is like a linear interpolation. Okay, so let me save this. So we have only done along x-axis. We have informally distributed along y-axis and z-axis. Okay, got it? So let's save it. CD double dat. Now blockMesh. Let me open this .foam again. Okay, so you can see, I think. Okay, so this size is longer compared to this width. Okay, maybe I can give some more larger value. So let's put around 5. Okay, now you can see. So the size, the width of the means ratio of this width by this width equal to the 5, and other cells will be linearly distributed. Okay. Similarly, if you want to do in the y, so you need to modify this second one. And since we have only one cell in z direction, so there is no meaning of modifying this simple grading in one direction. Got it? Exactly. That was my next question. So suppose we want this cell smaller fine meshes, this side finer meshes, this side finer meshes, this side finer meshes, and we want that middle one would be larger size. Then what will you do? So that was my next question. I am saying that like here only x direction has the smaller size. Suppose we want a block where this side should be finer, this side should be finer, this side should be finer, and this side should be finer. Only middle cells should be larger size. Okay, because why this issue should be there? Because the turbulence model, we generally use this means finer mesh for the turbulence model. Okay, and this turbulence means intensity should be captured near the wall. That is why this finer should be mesh should be there near to the walls. And suppose we are doing some flow like flow through a channel. So in channel, the top wall is also a wall, bottom is also a wall. In that scenario, you need a mesh where refined mesh is required at the top wall as well as the down wall. So what in that scenario you will do? Huh? No, edge grading is similar to the simple grading. There is means slightly different technique is used, but both things will do the same thing. Okay. So what you can do, you can simply take multiple blocks. So we can divide this block into the 4 different blocks. Okay. Got it? Suppose we have taken this 4 block, and we can use simple grading for this wall, then for this wall, and we can keep this middle wall as a larger size. Similarly, we can do this similar to this for this block. Similarly, we can do this for this block, and similarly we can do this for. So we have to take 4 blocks. Okay, and that you can see.
So what if like the edges do not match?
No, you are. So let me show you example. So first you will create the vertices, I think. First you will create the vertices, and using those vertices you are creating the blocks. And for creating the blocks, you need to follow the right hand rule. Okay, so 4 points should match with the 4 points. Then again this 4 points should match with the again those 4 points. This 4 points should match with the that top 4 points. Got it? So in that way you are creating 4 different blocks. Now you are means of course you are creating by yourself, so that way you can define the number of cells in a given one block. Okay, understand? If you're not well to understand, then next example is on that same scenario. Okay, so let's open that example. I think that then you can correlate in better way. So let's go to the case number 2. So if you go to the system folder and then blockMesh dict, so you can see that we have 4 blocks. See, so you have this block, using this 8 vertices, then again this 8 vertices, then again this 8 vertices. Okay. Now this is like we have in Z direction, we are keeping as a one cell because we are using 2D problem. Okay. So for this block, we are taking in X direction 2:2 ratio. For this block, we are using 0.5 and 2 ratio. Okay. So let's go to the first run this, then I will visualize that, then I will show you that how this ratio works. So then again run blockMesh. Case 02.4. Explorer. Okay. So if you go to the surface with edges, I think you can see here. You can see the ratio. You can find that there is a non-uniform grading. Now let's open the blockMesh dict. Okay. So there is 4 blocks. This is one, this is second block. 1 minute. I think I have one Python script also. Okay, so if you have Python, you can run this script. Python blockMesh vertices. If you have Python, you can run this. Otherwise, I'm showing that what I want to show that. This script is given here. See, if I load this vertices.vtp, okay, so you can see that there are, I think you can see this number of points. So these are the total vertices that we have created. Are you able to see? So using this vertices, we are creating total. I think you can see that there would be total how many blocks? 4 blocks. 1, 2, 3, and 4. Okay. So similarly, there is a this total 4 block. This is 1 block. This is 2 block. 3 block. This is 4 block. Okay. Now for this block, see, this is important. For this block I am talking about. Okay. So this is the int cell. This one. Let me. So I am speaking about this block. Okay. Now you can see. So this is the end cell and this is the first cell. You can see that the ratio would be around 2. For x-axis, this is the end cell and this is the first cell. The ratio would be 2. Okay. Similarly, along y direction, this is the end cell and this is the first cell. So the ratio would be 2. Okay. So that is why you can see that 2 and 2 for this block. This is the first block. So along x, ratio is to 2, along y, ratio is to 2. Now let's go for the second block. So this is the second block. Okay. So this is the first cell and this is the last cell. Now the ratio would be 0.5. Okay. And for this, for y direction, this is the same. So that is why you can see that for x, ratio is the 0.5. For y, ratio is the 2. Okay. Similarly, you can do for the bottom blocks also. So this is how simple grading works. Okay. Now you can run your solver if you want. Maybe I think icoFoam should work. Okay, because we are getting error because here start time is 0.5. This should be 0. Okay, so you can run your simulation. And now if you plot, because we are using the simple grading, your profile would be more, means I think more, what I can say, more clear. Yeah, 0. Start from 0. Okay, so you can see that the same case that we started, now we have more clear picture of the velocity. Similarly for the pressure. Okay, so if you further increase the number of the cell size, like we have taken 20, you can increase the more numbers, your solution will be more accurate. Okay, and how much number of cells you should take, that is something called as the grid independence test or mesh independence test. Because in case for the simply icoFoam, if you are taking around 100 cell in one direction and 100 cell in one direction, that we can say that misuse of the computational resource. Okay, so that is why you should perform the grid independence test. So what should be actual number of the cells, and then you can perform the cells. So that is something means about the OpenFOAM. And if you follow, if you want to more resources related to blockMesh, then you can go through this content. I will share you the link, and I have also one, I think, GitHub link that you can go. I have listed all the, yes, I will share you. I have listed all the free contents related to the OpenFOAM. Here you can go that and you can see that different videos. Okay, now still 1 hour is left, so I think I would you can have some feel about the OpenFOAM programming. Okay, maybe this control dict. Okay, so to check about the timing, you can go to the system folder, and here there is one control dict file. Okay, so that you can use open into your editor. Okay, so first thing is written that what solver you want to use. Okay, and second is the where you want to start, that is your simulation time, where it will start. Okay, got it. So here there are different options, like you can have another option that is the latest time. Okay, so suppose you have done simulation up to the suppose 10 iteration, your last folder is the 10, and suppose your power off, so you don't require to start from the 0, you can use this latest time. Okay, so it will start from your last saved folder. Okay, so that is another option that you can use here. Got it. And again, if you want to check that what are the other options, then again you can use this banana technique, like you can no start time, when the simulation will start. Okay, so like when I am running icoFoam, and if you see that it will start from the 0. So it will start from the okay. So this way you can, whatever you are printing on the terminal, this technique you can use to copy all the things into this text file. Okay, so you can see here that there is one text file with the name of the log icoFoam. Okay, so whatever you are seeing on the terminal, that will be saved inside this text file. Okay, so that we can see here. So you can see that your simulation, your 0 starting from the 0, then it will go to the next time step. Okay, so suppose we want to start from the 0.3, so let's remove other folder. So to remove the folders, you can use this rmrf command. So suppose we are removing 0.4, 0.5 and 0.6 and 0.7. So you want to remove these things. Okay, so now we have 0.2, 0.1 and 0.3, and we want to start from the just 0.3 folder. Okay, so that way you can go to this control dict, and here you can put your latest time. Instead of the start time, you can type latest time, and you can comment out this. Okay, let's remove this log file also. So now if I print this log file, so see it's starting from your last folder, that is the 0.3. Okay, 0. That that you can also use. Okay, that will do the same, but suppose you have a like 1000 folders. In that way, if you want to start from the last folder, that would be more appropriate. Okay, got it? Yeah, so you cannot say that is the second. Okay, yeah, some unit. Let me show you that where from where it is you are defining this timing. Yeah, I'm explaining complete control dict one by one. Let's go. Yeah, let's understand this folder, then you will understand this. You have now okay that what is start from and what is start time. Now this is the stop time. Stop at, that is the end time, and end time is given there. Okay, so there is two things. One thing you are trying to solve the transient problem, and one thing you are trying to solve the steady state problem. So in steady state there is no meaning of the time. Okay, because this is not a temperature dependent, time dependent solution. So in that scenario, this step, that is the 0.1, 0.001, 0.002, that is the number of iteration. There is no value of time instead of the steady state. But in case of, if we are speaking of the transient solution, then it is the time, that is the second. So that is a 0. So it will start from the 0. It will take delta t is equal to the 0.0025. So after 0, the next time will be 0.0025. Then again, this is the 0.005. Got? So this is the delta t that is following. Okay, and it will stop at the end time. So we are giving end time equal to the 0.7. Okay, so it will go 0.0025, then 0.005, similarly 0.0075, and that will go up to the 0.7. Okay, but in steady state it will automatically stop when convergence is reached. Okay, because in steady state there is no meaning of the time step. Okay, and this is write control, something the folder is written. So how many time step you want to write one folder? So that is the time step. Okay, if you want to again check what are the other options, that you can use the banana technique. This purge file is very important. Purge file is something, suppose you have big, suppose you are solving a big problem and where meshing is only up to the 1 GB. Okay, so like I have done one CFD-DM problem, my mesh only polymesh was around 1 GB. Okay, polymesh folder is only about 1 GB in my case, because I have around more than 1 million cell. Okay, so in that scenario, suppose you want to have steady state solution. So apart from the last folder, all the folders are the garbage. Okay, so if you just want to keep only last 2 folder or 3 folders, so you should put here 2 or 3. Okay, got it? What I mean to say that let's keep here 2. First, right, let's keep here 2. So it will save only last 2 folder. So it will start from the 0.1, 0.2. It will save it. As soon as it will create 0.3 and 0.4, it will delete other 2 folders. It will only save the last 2 folders. So because we want to, so if you start from 0 to 0.7, and if you keep this delta t equal to 0.0025, there is a number of folders. So we want to say that only after 40 iteration you keep 1 folder. That is the meaning. Okay, got it? So 0.0025 multiplied by 40 equal to the 0.1. So you can see that only 0.1 folder is being saved. So again 40 times equal to the 0.2. So again 0.2 folder is being saved. So that is working like that. So because if other folders will be won't require that much. there's in control dict you cannot change the convergence criteria. Control for convergence criteria, it says that you have to go to the FV solution folder. So you have to change the relaxation factor, you have to change the relaxation tolerance. So these things you can control inside the FV solution. Yes, that you can do. Use you can reduce the time step. Okay, but there is one option. This run time modified table, so that if you put true, it will automatically take the optimum time step. Okay, if you keep this true, this is not going to take this delta t if it will require. Okay, so maybe in multi-phase problem we use this run modifiable time level, so it will automatically take 1 e to the -6 something like that. Okay, that coherent number should be less than around 1, I think. Yeah, of course. So it will take the delta t based on the coherent number. Okay, so that you can use for the, so this is the purge write. I think you can understand what is the purge write. Okay, this write format, so sometime you can save your folders in the format of the binary files. So there is two options, one is the ASCII and one is the binary. This is the precision. Precision means suppose you want to calculate the pressure drop, so after decimal how much precise value you want to take, that you can increase if you are solving some such kind of problems. Okay, this write compression, so if you want to this 0 point the different folders in the form of the zip file, that you can turn on this. Okay, this is something if you have a very big kind of meshing and very large time step you want to simulate, so these are the something that you can use that. Okay, now another important thing is that different dependent library that you can also put inside the control dict. Okay, so maybe I will share you one general control dict file like I've shared about the blockMesh dict, that you can go through that. And I have, so here if you go, so I have given one readme file. Okay, so you can understand what are the different syntax inside the blockMesh, so that I've written here. Similarly, I will share you one file for the control dict, you can understand the different syntax. Okay, now I think if you want to learn about the programming, so we will do only one programming just to have familiar with you. So I think I should hand over to the Nikhil. लेकिन उसका साइज थोड़ा सा छोटा है. इसको भी रख लगा इसमें माइक्रोफोन से है. सबके माउस है तेरे पास? नहीं कैसे चाहिए? मेरे को फोल्डर स्ट्रक्चर में जाना है तेरे को, यहाँ से ये ना ओपन फॉर्म इसमें जाओ. ओपन नहीं मैं वहां से समझाना चाहता हूँ जीआई से. ठीक, किसमें डाउनलोड?
रन कहाँ है तेरा? रन फोल्डर इटरेशन 9 है। ठीक है। So now we are going to start with the basics of coding in OpenFOAM, right? So we will go through what is inside icoFoam solver, and then we will try to modify this icoFoam in order to add the temperature equation. So in order to do the basic coding, there is a command that is called foam new app. So if you type just foam new app and the name of the solver, it will create files and folders. Let's try to do this. Go inside run folder. Are you inside run folder, right? Now what you have to do is you have to type this command foam. This is the command you have to type, foam new app. And the name of the solver, right? So the name of the solver, here we are trying to do the very basic coding, that is we are trying to print hello world. So we are just typing the name of the solver as HW, hello world, right? So as soon as you type this command, you see that it is creating application code directory HW, and then it is creating make subdirectory, and then it is creating create fields.h. So if you go inside HW, cd HW, you see that there is .c file, and then there is a make folder, and then create fields.h, right? So if you just open this hw.c, right, what you can see here is the name of the application is HW. Is that clear? Like initially we are trying to simulate various problems, like we have tried to simulate lead driven cavity problem where we are typing icoFoam. So the name of the application for that problem was icoFoam, but here the name of the application is HW. Is that clear? Now these are the basics header files that OpenFOAM uses, that is hash include fvcfd.h. It should be there in every OpenFOAM .c file. Now since we are doing very basic problem, what we are doing is let's remove all the things that are given here. So there's nothing inside this main function. So what we are trying to do is here is we are just trying to print a basic information. What? नहीं यार, वो ऐसा नहीं बनता, इसको बड़ा करता यहाँ से
इसको यूज करना जीनी को जूम इन बार बार करना पड़ेगा।
So now what we are doing here is we are just trying to print a very basic information, that is hello world. So here we are just typing Is that clear? I think everyone is following till here. Now close it. After making the changes, close this .c file, and then what you have to do here is, now since we have made a new solver, what we have to do is we have to write a command that is called wmake. So once you uh, write wmake, it will create dependency, and then finally it is saying that it has created a solver. The name of the solver is HW, right? Then if you type HW, like initially what we are doing, we were typing blockMesh and then icoFoam and then paraFoam. Here what you have to do is you have to only type HW. If you type HW, you see the information is printed here, right? Is that clear? Now let us do some more operation inside this uh, .c file or in this solver. Now let's say we want to do the basic mathematical operations like addition, subtraction, multiplication and division. So for that, what you have to do, let's say just write what I am writing right now. Please type the following thing: info, and then in double quotation a plus b, and then again a plus b and l. So what we are trying to do is, first of all, we are adding two number and then subtracting two number and then multiplying two number and then dividing two number, and then also we are trying to find the modulus of the two number or the remainder when we divide one number with another. So these are the operations that we are going to perform, right? But as you can see that right now we don't know a and b, so we need to define what is a and b. So in order to define a and b in C++, what we have to do is, first of all, we need to understand what kind of number we are entering. So let's say we are entering, let's say integer. So for that we have to type int. Int is the data type for the integer. Let's say the variable name is a and b. This is what we have defined, right? A plus b, a minus b, a into b, a divided by b. So a and b we have to define initially before the operation. Then we need to, since a and b are integer, then we need to substitute integer value of a. Let's say we are defining the a to be 9. And after every line we need to put semicolon. And then let's say define b is equal to 2. I'm also printing the value of A and B. So I have made the changes, right? I have made the changes inside the solver. Initially, I have written hello world. After that, I have made the modification and I have performed the basic mathematical operation. So first of all, save this file and close it. Now you can't directly run HW because you have made changes in the solver. For that, you need to clean the previous solver so that it will clear the previous dependencies. For that, you need to type wclean. Once you have typed wclean, then what you have to do next is you have to again type wmake. It will again try to create dependency for the new things that we have done inside the .c file, right? Then if I type hw again, the name of the solver, it will show hello world that we have typed initially, and then now we have added basic mathematical operations where a is equal to 9 and b is equal to 2. So the summation of a and b is 11, a minus b is 7, a multiplied by b is 18, a divided by 2 is actually it's 4.5, but it will never show 4.5 because we are dealing with the integer. So it will give us the value equivalent to 4, and the remainder in this case is 1. So it will show the value to be 1 for a percentage b. Is that clear? So again, everyone is following, right? Anyone facing problem, please raise your hand. Now let's change the data type of a and b. Let's change it to double. What does double means? That a and b variable now can take any decimal value like 9.45 or something else. Let's make it to double and let's change it to 9 point, let's say 667. Any random value you can add. Save it, right? Again, what you have to do is after saving and closing it, again what you have to do is the first command that you have to write is wclean and then wmake. Now it is throwing some error because when we are dividing one decimal with another decimal, you can't, that remainder will not be necessary a integer value. So this a percentage b will not going to work for double data type. So you have to comment that data type or you can remove that operation. So we are going to remove this operation, that is a percentage b. So we have made changes in the solver. So every time we have to type wclean whenever we made changes in the solver. So the comment symbol is not working here. So what is the command? Slash, okay. Oh, sorry, sir, double slash. W clean and then again W make. Now it worked, right? Now again you type name of the solver, then now it is able to perform the operations related to floating or double point variables like 9.667 and 2.435, and the results are shown in the screen. So this is the basic of how to do the basic mathematical operations in OpenFOAM, and why it is required, because let's say if you are trying to solve any problem, we need to show what results it will going to show after the simulation. For that we need to inform to the audience that these are the parameters that are relevant. Let's say a drop is falling, let's say in a rainy season the drop is falling from cloud to the ground. So let's say someone is interested to simulate the falling of a droplet, then what you can do is you can track the centroid of the drop. So in order to track the centroid of the drop, you need to code certain things, and this coding is required while post processing. So you can code similar things inside the .c for in the C++ file. Is that clear? So we have done with the hello world example. Now I want to go through the icoFoam solver again, because some people are confused with the icoFoam solver. So what is icoFoam solver? It's transient solver for incompressible laminar flow of Newtonian fluids, right? So when we try to solve any fluid flow, uh, it can only be possible through Navier-Stokes equation, right? And Navier-Stokes equation and continuity equation. So if you look into the continuity equation, there is this term, this expression, and when we look into the momentum equation, there are three momentum equation: x momentum, y momentum, and z momentum. So if you look into the equation, how many unknowns are there? There are four unknowns: u, v, w, and p, pressure. But and also there are four equations, right? So but we know that if there are four equation and four unknown, we can solve the equation. But it is necessary that all the equations should have all the four variables, but the continuity equation does not contain pressure, right? So we have four unknown in x, y, z, but only three unknown in continuity equation. So that is the biggest problem in CFD of incompressible flow. So how to solve it, right? So the way to solve is predictor character approach, that is through the iterative solution. What you have to do is, something is not working. Okay, I will explain from here. So what you have to do here is, since the analytical solution of all this equation is not possible, so what the first step we have to do is we need to predict a value, right? So what we are doing is, let's say we are predicting the value of pressure, right? Let's assume anything, any value you want to put it inside x, y, and z momentum by assuming any value of p, correct? So we will get some value of u, v, and w from all these three equations, right? But does that mean it will satisfy continuity equation? No, because we have just predicted any random value of p. So in order to get the correct value of u, v, and w, we need to utilize the continuity equation, and we do it by using predictor and character step. That is, we are first predicting the value of pressure and then calculating the velocity and then substituting the value of velocity in the continuity equation. Ideally we are expecting the summation to be zero, but numerically it will never reach to 0. So we need to set a tolerance limit. Till what tolerance limit we will accept the value of u, v and w. So generally we keep the value of tolerance limit to be 10 to the power minus 6. That I will going to show in the FV scheme and FV solution of the solvers. Now after that we are going to add a temperature equation or heat or energy equation in the icoFoam solver. You might have run the simulation, right, and you have seen the field for velocity and pressure, but there was not temperature. Now we are going to add temperature equation in the icoFoam solver. So what is actually a temperature equation or energy equation? It's nothing but we have d by dt, which is advected by velocity and it is diffused by thermal diffusivity, right? So we need to model this equation in OpenFOAM. So if you just open this each of the term, this u dot uh, gradient of t will look like this, and this uh, that is Laplacian of t will look like this, right? So as you can see here, the initial part, that is the icoFoam solver, which calculates pressure and velocity through predictor character step, right? And finally we get, after setting certain tolerance limit, we get the values of pressure and velocity. Now in this equation we already know that u, v and w, right? But the temperature is unknown. So this is called one-way coupled. One-way coupled because the temperature is only dependent on the velocity. The velocity is not dependent on the temperature. But if you look at the previous slide, where pressure and velocities are two-way coupled. Velocities are coupled with the pressure, and pressure is dependent on the velocity. Is that clear? That is called two-way coupling. So the two-way coupled problems are solved using iterative solutions. But here, since it is one-way coupled, because we already know the value of velocities u, v and w, so and we have only one equation, one unknown, so it can be easily calculated, right? So how we will write this equation in icoFoam solver? First of all, we need to understand what we are trying to calculate. So we are trying to calculate temperature, and we know that temperature is a scalar field. For this reason, we have written this command, that is or the line FV scalar matrix. Let's say if we are trying to calculate certain parameters which are vector in nature, then in that case we need to write FV vector matrix. Is that clear? So for temperature we need to write FV scalar matrix, then T equation, the name of the equation, that is T equation. And this dt by d time can be written as FVM ddt of t, and this u dot grad t can be written as FVM divergence phi t. Phi here is equivalent to u, right? And here, so this term is called advection term, and it is shown by this expression, that is divergence of phi t. And now we have the another term, that is called diffusion term. This diffusion term is nothing but Laplacian term. So in OpenFOAM there is one advantage, like you don't have to type everything. If there is certain pattern, like if in any expression, let's say the temperature has expression, the temperature is coming in the form of nebula square t, that is Laplacian. So you don't have to code for the entire Laplacian. All you have to do is, the Laplacian is already available in the OpenFOAM. All you have to do is, you have to just substitute the constant value and the variable value. Similarly here you want to calculate the divergence. So what you have to do is, the divergence operator is already available in OpenFOAM. You have to just substitute u and t. Similarly, the ddt operator is already available in OpenFOAM. What you have to substitute is t. So these equations is now ready in OpenFOAM. And one more thing, like here the right hand side is transposed to the left hand side, so the negative sign will come, and I have not written equal to 0. You can write it equal to 0. If you don't write it, by default the OpenFOAM consider it as equal to 0. Is that clear? And then finally we are solving t equation dot solve. Here we have only written the equations, and here we are solving this t equation. Is that clear? Yeah. So like do you know the term viscosity? Viscosity is nothing but diffusion, which is a molecular phenomena which diffuses with respect to time in all the direction. Similarly, there is a term thermal diffusivity. When we deal with the heat conduction equation, there is a term called thermal diffusivity. So this dt is nothing but thermal diffusivity which happens because of gradient in the temperature. Is that clear? Now we are going to implement so u is nothing but phi. So every time, let's say, so if you want to understand any equation, let's say, so what happens is the meaning of this equation is this, let's say this is the equation, then the first term is called temporal term. Temporal term means something that changes with respect to time. And then there is called advection term. What do you mean by advection? Let's say you burn agarbatti, right? So if you just burn the agarbatti, what happens? The smoke will diffuse in all the direction equally. So that phenomena is called diffusion, and that happens because of molecular diffusion. But let's say if you just burn agarbatti and it is giving smoke, and let's say you started fan, right? So what happens? Because of movement of bulk movement of air, the smoke will travel in one direction, and the direction is the direction of velocity. Is that clear? So this is the meaning of second term. The t or the any quantity will move because of the bulk motion of this velocity. Is that clear? So every time how OpenFOAM codes is, there will be a phi available here. So whatever you write here at the in front of this grade t, it will be taken by this phi. Let's say if you change the term, let's say you are writing t dot gradient of u, then t becomes phi, and this, and here you need to write u. Is that clear? Now let's try to implement. Yeah. So alpha term is constant here. Yeah. So here, if you look at the Laplacian, so what is Laplacian? D square u upon dx square, d square u upon dy square. But let's say there is a constant. So that constant generally in the diffusion term of the Navier-Stokes equation, we have mu d square u upon dx square, mu d square u upon dy square. So the mu is taken as a constant. Maybe in some cases it will depend on temperature. That is another research problem where this diffusivity or viscosity is a function of temperature. Then again you need to write one more line of the code so that you can calculate this alpha as a function of temperature, but that is too much advanced. Here we are dealing with very basic problem where this thermal diffusivity is constant. Is that clear? Yeah, phi represents u. Correct, correct. Yes, 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 yes. So that is the advantage of using OpenFOAM. You don't have to code everything right from scratch. So these are the you can say the commands that are available in order to perform the CFD simulations. Is that clear? Now let's go to the installation directory, right? So what we were doing from first day, we have installed OpenFOAM, right? And OpenFOAM is installed somewhere, right? So since it's the root directory, right? So we can't make changes in the root directory. So what we are doing is we are copying the file, right, and pasting it somewhere else, and that location is called our run folder. So every time we want to do the new simulation, we need to copy it from the root directory and paste it on our run folder. So whatever changes we make, it will not reflect in the root directory. Is that clear? So let's go into the solver. So if you look into the, if you go inside the solver and then incompressible and then icoFoam, you see what I have done initially. I have used a command that is called foam new app, foam new case, and the name of the solver, and you find that .c file and create fields and make folders were created initially. Similar structure is present in the original solvers of the OpenFOAM, right? So what we are doing is we want to modify this solver. So let's copy this solver and paste it in our run directory. Is that clear? So what we are trying to do is, now we have original icoFoam solver. The icoFoam solver only calculates the pressure and velocity. Is that clear? Now we are going to add temperature. So what you have to do is you need to modify the solver. So what the first step is to modify the folder itself. So everyone is following till here, right? Copy the icoFoam solver from the solver folder in the root of OpenFOAM to the run. Okay. So I think we need to stop it then. Okay. So we will going to upload the videos related to what we are teaching now, so that you can follow it later, right? Because there is another program that will going to happen right now. So we have to end our session now. Is it? Yeah, we can take. I mean, it depends upon your interest. If you are showing interest to learn OpenFOAM, we will be happy to teach you OpenFOAM, right? Or you can just contact Pratyush or me if you have some problem related to OpenFOAM. We will going to help you. Is that clear? So we are going to stop the session now.
I was in and to everybody for everything and the standard people also. So I'll be sharing the feedback form the link that is worked. Just try to put the feedback and put the and just fill that. So, need appreciation thing. So,